Brought to you by Accenture Extended Reality. This is Field of View.
Hello and welcome to Field of View. I am Nick Rosa from Accenture.
And hey, I'm Daniel Coliani from AIXR. And today we're speaking to someone who really got their start in electrical engineering, computer engineering, and mathematics. And I would say it's really safe to say that they are a serial entrepreneur. They've gone on to found companies that have gone public, including other organizations that have been acquired by Sienna and also even Nokia. Nick, do you want to tell us more about them?
Yeah, so today we're going to talk about the future of augmented humans. We're going to talk about invisible augmented reality and invisible computing. It's a pleasure to have with us the CEO of Mojo Vision, Drew Perkins. Hi, Drew. How are you doing?
Hello, I'm doing very well. How are you, Nick?
Very well, very well. Thank you for being with us today.
Okay, well, look, I think it's really interesting, and I think I don't know about you, Nick, but I jumped on the moment when I was looking online and I was looking around, and Drew, I think it's safe to say your new company, kind of Mojo, has really made a bit of a buzz when it comes to invisible computing and how we can use augmented reality kind of devices that can fit within the size of a contact lens.
That's right. We've been talking about this for the last year and a half or so, but we've been under development for the last 5.5 years, and we're really looking forward to bringing this technology to market over the next few years.
No, that's great.
Can you tell us a little bit about the idea behind Mojo Vision? How did you come up with this idea of fitting so much technology and such a complex device like computer vision and augmented reality devices into a contact lens?
Well, I've been a high-tech, deep-tech engineer for many years now, an entrepreneur. And as Daniel mentioned, I've started several companies in the deep tech space like Infinera, and it's all been about nanotechnology and making things really, really small and incredibly powerful and fast and high performance, deep semiconductor technology. And while I was developing my last company, I also developed cataracts in my eyes, and I had cataract surgery and these things called intraocular lenses put in my eyes. It's the most common surgery on the planet. Most people, when they get into their 60s, 70s, maybe older, sometimes younger. I was much younger, and there's a genetic component to that. And they put these small plastic devices that replace your normal crystalline lens. The crystalline lens is what allows your eyes to autofocus, basically, and focus on things that are near or far. And these intraocular lenses don't have that ability to autofocus like that. I got a pair that allowed me 2 different focuses, a near and a far, but nothing in between. And even though it was a 10-minute operation, I woke up and from the operation, I could see again. My eyesight was failing with the cataracts before that. And 10 minutes later, coming out of the operating room, I could see crystal clear, near and far, but I quickly started to notice that I couldn't see at intermediate distances. And I thought to myself, why on earth isn't there bionic eye technology at this point? At that point, it was 2012. And I thought, when I was a child in the 1970s, and my favorite TV show was The $6 Million Man, Steve Austin was the bionic man, and he had these incredible vision with his bionic eyes. And I thought, why doesn't that exist today? I thought, someday I'm going to go invent that technology and my next company. So when I got around to the point of wanting to start a new company, it was the natural thing to go investigate and get started.
Wow.
Sorry, go on, Daniel.
No, I was just going to say, Nick, you continue, but definitely that's really interesting to hear that origin of how that, that thought process went into this tech. And I think, most people would just, sit there and deal with it and think that's it. But I guess you've gone off and think, no, I'm going to do something about this.
I've started a number of companies, as you noted, and each one has changed the world in some way. And that's been my goal, to change the world, improve humanity. And this, I think, will be my greatest contribution to society and humanity once we get this technology working and shipping.
Augmented reality contact lenses seems something coming from sci-fi movies, a little bit of a Minority Report feeling. But you told us that you built and created so many companies that changed the world in some way. Would you like to take us through the journey of your entrepreneurship and all the companies that you build that are changing the world right now?
not just companies, but technologies. So when I was at Carnegie Mellon University in the 1980s, working on my engineering degrees, I was in the right place at the right time and managed to become one of the founders of the internet, basically one of the early innovators that developed the internet technology that we use every day. And at that point in time, we needed the first way to dial up into the internet. So I created a technology called the point-to-point protocol, PPP. And that, of course, went on to be one of the foundational pieces of the internet. In about 1987 or so, I started my first company as an entrepreneur, and it was one of, if not the first, Ethernet switch company. I didn't know quite what I was doing as an entrepreneur. I knew what I was doing as a technologist, but I didn't succeed at that one. Later in the mid 90s, I joined some colleagues of mine that had spun out of Carnegie Mellon, and we did create a switching company called 4 Systems that I joined in 93. We took it public in 94, and by 95, it was the backbone of the internet for all long haul communication and the backbone switching layer, and remained that way for the latter half of the 90s. Then in 97, I started working on what became Lightera and ended up being acquired by Ciena, as Daniel noted. And that technology, optical switching technology that the company I co-founded created, it went on to become the backbone of the worldwide telecom network pretty much, and sold billions and billions of dollars of that equipment. Coming out of that, I co-founded to Infinera in late 2000 based on the experience I'd had, everything passed. And Infinera went on to develop photonic integrated circuit technology, incredible deep tech semiconductors that integrate optics like lasers and detectors and modulators and optical combiners and switches and things, all into small little chips. And all the ASICs and all the systems and all the software and network operating systems, all based around that. And Infinera, by 2004, when we shipped, was the leading product in the optical transport wavelength division multiplexing space, WDM as it's called. And that allowed us to go public in 2007. Coming out of that, I started one more company, Gainspeed, as Daniel noted, that was acquired by Nokia at the end. But we reinvented the cable network. The cable networking companies like Comcast and Charter and Cox and Cablevision all wanted a better switching system than they were getting from Cisco and other people. And so I reinvented that network architecture and started the company to do that, along with some colleagues and co-founders. And today that product is shipped around the world and is serving internet to a lot of people's businesses and homes. So Wow. It was natural for me when I had this idea for Bionic Vision to co-found a company again that would develop incredible componentry that would be enabling for this incredible science fiction formerly, and turn it into science fact. And today we have turned it into science fact. I've worn several generations of lenses on my eye that have given me augmented reality. So have a number of my colleagues and even some outside optometrists at this point. And we're really looking forward to bringing this technology to the world, because what it can do is just going to be phenomenal.
So Drew, just for a moment, I want to step back from the augmented reality side of things, and I just want to get in for our listeners and our viewers, get into the mind of what a serial entrepreneur kind of looks like. Because I guess there's also this temptation, right? When you set up a company, it's successful and it's making revenue, and but what's that mindset like? I guess for you to have to to set up a company and then I guess move on to the next big thing, and then again move on to the next big thing. I mean, how does that work in your mind?
Well, each time it's been a little bit different, and it's things going on in business, is things going on personally and family and everything else. But in one case, it was quite easy to leave the company because we sold the company. In another case, it had gone public and I stayed several more years, but I was getting itchy to do something new project, and had ideas, and Infinera couldn't go where I wanted to go. So it made sense for me to go independently and start it. So I as a person, I get itchy after a little while and want to do something new and fun and really break new ground on a constant basis.
And what I mean, to anyone out there that is perhaps, in the middle of setting up their organization and kind of doing all these things, what are some of the key learnings that you've learned along that way from, the beginning to where you are now?
One of the big things is that I try not to have any self-imposed limitations and think big. And I think that the best thing to do is identify a big problem, figure out what technology is around or could be around that could solve that problem. And if it's a big market, you're likely, if you can succeed at the technology and build the business, you could be very successful. So I just like to think big and not be constrained in how big I can think.
Yeah.
So.
I am fascinated by this concept of the bionic man and obviously wearable technology that is completely invisible. Can you tell us a little bit more on how it works, actually? Obviously, you don't have to spill the beans on any of your secret sauce and patents here publicly on our podcast, but we would like to understand a little bit more how this magic is working in some way.
How's it possible? Yeah.
Sure. Well, what we're doing is taking all the power and capability and features of your mobile phone and sticking a lot of them into the contact lens, and then some things still stay outside the mobile phone or outside the contact lens in another device that may be your mobile phone or maybe some other wearable device that you have on your person. But if you look at your mobile phone, what's the first thing that dictates its size and even its power? The screen. Well, so we're taking the entire screen off the mobile phone, and we figured out how to shrink it down to something that's less than 1 millimeter in size and stick it in the middle of the contact lens and display information directly to your retina that can look like it's coming off your mobile phone or look like anything that you see at the end of the day. And so to do that, what does it take to do that? Well, first it takes power. So we've had to figure out how to integrate power into a contact lens. It's not just a simple, dumb piece of plastic anymore. It's a simple, dumb piece of plastic, but it has components inside it. And first thing it has is we've integrated battery technology. We've developed thin film, solid state, biologically safe battery technology that we hope will power it all day or a substantial number of hours through your day. And with that power, we can then do things. We can do computing. So we've integrated a microprocessor directly, an ARM core microprocessor directly into the contact lens for doing all kinds of
on the contact
tasks.
lenses. The
Directly
microprocessor is there. Oh my God.
Yes. The next thing it has to do, of course, is it has to communicate. So it needs some place to get the information that it's going to show to you, display to you. It needs a way to communicate with the cloud. So we've integrated a high-speed radio, a modem, directly into the contact lens that can talk to this other device that we call a wearable accessory, a relay. And that relay can then talk Bluetooth to your mobile phone, which can talk LTE, 4G or 5G to the cloud, or that wearable accessory can talk Wi-Fi directly to the cloud and therefore all the servers in the cloud. So the computing experience and computing technology, part of it's in the lens, part of it's in the relay, part of it's in your mobile phone, part of it's in the cloud. Just like today, your mobile phone has computing on the mobile phone, but part of it happens in the cloud too. We've just added a couple more devices in the chain, and they all communicate together, and between them, they do all the computation that you're going to need. The next thing that's in the contact lens that's in your mobile phone is sensors. Your mobile phone, when you move it around, it detects what direction you're going and what direction you're pointing, and it knows when you're turning it and twisting it and moving it around. And that is done through IMUs, inertial motion sensors, basically accelerometers, gyroscopes, and magnetometers, tiny little devices, tiny little sensors. We've integrated all of those directly into the contact lens, so we can tell when you're moving your eye, how fast, how far. We can tell what your eye's looking at, basically, which direction you're looking and which direction you're moving, etc. So all that's integrated in the contact lens. Then there's an image sensor. We want to understand, in order to help you remember things, to help you control things, help you do any activities. We have a small, very low resolution image sensor that's directly in the contact lens. It's not good enough for taking pictures, not good enough for doing video and putting on Instagram, but it is good enough for computer vision. because computer vision doesn't need all that many pixels. And so with that, we can then download the information that's coming off that image sensor. We can put it in through image processing, AI, computer vision technology, and we can do all kind of things to recognize what we're looking at, recognize a stop sign if we're looking at a stop sign, or recognize we're looking at a person, recognize we're looking at our phone, we can recognize we're looking at our steering wheel, etc. And through that, you can do all kind of experiences that your phone cannot do today, because you're not carrying your phone in front of your face at all times. Whereas
so
now
how do you like, so we've got this technology, and you know, I guess, like, you know, when I think about the CPU on one of our VR ready PCs that we've made, for example, and you know, that can be, like, let's say, you know, it can go down to the size of a quarter or something like that. You know, so can you actually say, what does it actually take to take something like that, or take a CPU and take all of these powers, even the batteries, and shrink it down in size enough to be able to fit it on a contact lens?
It takes the same thing it does even in your mobile phone, the continuation of Moore's law, the continued shrinking of ASIC, application-specific integrated circuit technology, the same technology that is used in your microprocessor in your desktop or in your phone. You know, companies like Intel, companies like TSMC build incredible chips at this point, and we're leveraging all the multiple decades, 5, 6 decades, whatever it's been now, of continued shrinkage of integrated circuit, deep semiconductor technology, and the ability to put incredible power on incredible small pieces of silicon. And then we're taking those incredible small pieces of silicon, putting it in a contact lens that's in your eye.
So Drew, is it can we create some actual scenarios of how these contact lenses could be utilized in a normal life to make this thing a little bit more real to people? I mean, the first thing that comes to my mind, for example, is in a room filled with people where you're doing networking, you could potentially connect your contact lenses to LinkedIn and get the names and job description of every person in the room, and eventually go to this person and even understand if this person likes you or dislikes you because of the micro expression and why you're talking to this person. Is this one of the applications that we could expect in the future?
Sometime in the future, we're being very careful introducing that level of technology. We can do that, but it's not clear the society is ready for that level of technology. There's an awful lot of ethics and things that have not been worked out in all the law regarding privacy and security and things like that we're being extremely careful about, so that people trust us that we're only doing things that both the wearer and the person being looked at are comfortable with. We want everybody to trust that it's safe to put this in their eye and it's safe to have that kind of information. But those things are absolutely possible. It becomes a software feature, software function at that point in time.
Sorry, go on, Daniel.
No, you go ahead. Go ahead.
Yeah, I was about to say that from big power comes big responsibility, just to cite one of my favorite Marvel characters. But anyway,
one of my favorite as well.
Exactly. My other question for you is, I mean, you are painting the description of the perfect electronic device. I mean, something that I would pay thousands of dollars to have even tomorrow. How all of this is ready and real already? And when do you think you're going to be able to ship this to the public?
See, I was going to highlight this.
Sorry,
yeah, I mean, this is what I was going to highlight as well. It's like, I know, obviously, we talk about this technology and being able to shrink it down, but like there must be some technical limitations at this point in time, right? Which we should expect to overcome, right?
There certainly will be technology limitations. It's been an incredible journey that we've been on, shrinking all these devices, but there's a long way to go as Moore's law continues and the semiconductor industry continues to allow us to make things smaller and lower power and more capable. Our first device, think of mobile phone technology. I'll use Apple's iPhone for a moment. The iPhone 12 now is so much more advanced than the iPhone 1. And there's been an incredible increase in capability every generation of iPhone. And I expect the exact same thing will happen with contact lens technology, NEAR technology glasses as well. And so we'll get more battery life, we'll get more features, we'll get higher resolution, we'll get better color.
What's the resolution right now?
Our goal
and where are you aiming for the, consumer device version 1?
We think in terms of two things. What is the resolution on your eye, and what is the resolution of your vision? And here in the United States, we talk about 20/20 vision. I understand you guys are in the UK and use different terminology, but I'm comfortable with 20/20. It means, perfect, not quite perfect, but very, very good resolution of your eye. And you can see things at 20 feet what other people, the average person, can see at 20 feet. Perfect vision actually is more like 27. If you have a sharpshooter in the military, he's probably got even better resolution than the average person. And it's at that point, really quite incredible. We're shooting in the very first product for just a little bit less, maybe 20/40 vision, which is still very, very good. And so the images are very, very crisp, but we absolutely have a path to get to 27 vision and give everybody superhuman that kind of vision that only sharpshooters might have. So that's one axis of the quality of the image that we are shooting at. The other axis is sort of how wide that is the image can be, how big it can be on your eye. The truth is that we all have a fovea in the center of our retina that has super high resolution, and that's where this 20/20 really sits, is directly in the fovea of your eye. And outside of that fovea is only a couple of degrees. So you really only have sharp vision within a very narrow couple degrees view. And outside of that, it falls off dramatically, exponentially, incredibly quickly. And your vision at your periphery is very, very poor. If you try to hold your hand outside your vision, try to count your fingers, you're not going to really be able to do it very well. You try to read out here, you're not going to be able to do it at all. So what we want to know is we got the central vision that's super high resolution, and then how far out can we go out into the periphery? And over time, that will increase to a point we know we can get to cover every cone in your eye, in your retina. But that'll happen over time as we have further and further generations, more advanced generations of product.
So when can we expect it? What do you think? And what it needs to happen between now and when we're going to receive we can go to a shop and buy our contact lenses? What do you think are the steps? Like creating an ecosystem of developers. It's more about, technology barriers that you're, facing right now. So you need to wait a little bit more for the miniaturization process to make the technology more fit for the kind of device that you want to ship to the public.
And I think, Drew, you picked up on something as well, which is it's not even a technological barrier, but it's actually, I guess, is a mind barrier for certain people to actually say, okay, I'm going to put this in my eye and I'm going to, let it, change the environment around me. Right?
Yes, exactly. So I've been on this journey going on 6 years now. And over that 6 years, 5.5, 6 years, we've knocked down many, many barriers to prove that this is possible. We've built many proof of concepts. I put, quite a few generations of this technology on my eye. And at this point, we are putting the finishing touches on our first. I distinguish between a proof of concept and a prototype. A prototype is much closer to a product. It looks and smells like a product, but it still needs another couple turns. Think of it more as the alpha, as opposed to even the beta version. So we are currently putting the finishing touches on our alpha lens, and I expect to be putting that in my eye very, very shortly. The next step will be to put it not just in my eye, but many people's eyes, and start to gain some experience and get some feedback on this needs to be improved, that needs to be fixed. We can make it better this way to be successful as a real product.
Can I volunteer? Please.
We are.
Both me and Nick volunteer.
We do intend to have a journalist be one of the first people that we put this on the eyes of, so that they can describe it to the world and vouch for us that we're not lying, because it's very difficult to prove that I'm not lying and that this is actually working. So in any case, we will learn from the first people that it goes on and our first experiences with it, make adjustments and fixes and improvements, and create that final version of the product. Then once we have that final version of the product, one of the intriguing things about a contact lens is it's a medical device. And as a medical device, it needs to be approved or cleared, certified by regulatory body, the regulatory body in any particular country that we want to sell in. And in the United States, that's the FDA. The EU has its own regulatory bodies, and I'm not quite sure what the UK is doing right now post-Brexit, but you'll have your own things as well. So we need to do clinical trials. We need to do testing on people's eyes to gather evidence to put it in front of the FDA and the regulatory bodies and prove to them it's safe as well as effective. And so we have that step to get through, and then hopefully we will get approval in the next few years and be able to sell it on the open market. So we got a few steps, and it's still going to be a few years away before we can sell it. But in that clinical trial period, we will be, looking for people that want to be part of our clinical trial and use it.
I mean, sounds
like
fascinating.
You've moved to the States. Drew, understandably, obviously you've just alluded to it as well, with regulatory bodies will want to take a look at this and make sure it's safe for use. I mean, so to someone listening at home right now, I mean, how do we actually go about guaranteeing the safety of essentially wearing a battery on your eye?
Oh, there are quite a few elements of that, quite a few things that we're doing. The first one is called toxicology testing. We need to prove that it's safe just from the material standpoint, that they're not going to cause irritation, not going to cause infections and various things. So we've already begun our toxicology testing of that and have already passed one of the key phases of that toxicology testing, and that'll be done in the next month or two. And once you know then that it's safe to put on, then there are other things. We've already shown the FDA that we're not going to blind you, that we're going to present safe levels of light to the eye, safe frequencies of light, et cetera. And it's going to be safe from, that perspective. We're not going to blind. We've also shown one of the things about contact lenses. One of the interesting things about human anatomy is that the cornea of your eye it's cells. It's a type of skin, basically, and those cells require oxygen just like every other cell in your body. But your cornea evolved to not have any blood vessels in it. It's transparent. If it had blood vessels, it wouldn't be transparent. At best, you'd see red probably. Because of that evolution, what happened was the cornea breathes through outside air. Outside oxygen has to flow to those cells so that they can live and breathe and grow and et cetera. And any kind of contact lens has to make sure that the oxygen can still get to the eye. Yeah, that it's oxygen permeable. And different types of contact lens technologies do that in different ways. But fundamentally the oxygen has to permeate through the contact lens. We've had to solve that problem as well as any other contact lens, and we've already proven that we can do that and collected the evidence to show, yes, our contact lens architecture works. And that was a non-trivial thing that we had to do, and it took us, several years to develop the technology to do that. So, but there are many other things that we're going to have to prove the safety of, that we're not going to distract you. At the end of the day, we want to make sure that we're not going to show you distracting images when you're driving or doing something that could be dangerous.
There's that Black Mirror episode I like to think about. You probably get it referenced a lot, actually, which was, I think there was one called like The Entire History of You, for example, where, they actually had, these contact lenses that you can put in. And, obviously this is media, so science fiction media, but, there's scenarios in that where, the person can look back at events of the day, and they can, ignore or blind out the world around them and things like that. So I guess there's those ethical concerns as well around this that we have to be mindful of.
Absolutely. We're all fans of Black Mirror as well, but we've produced a series of videos of our own that I like to call White Mirror, to show the good uses of it and all the good things that come out, not the bad things. This, like every other piece of technology, can be used for bad and evil as well as for good, and we're going to try to focus on the good and highlight those. But technology,
does that mean
every tool can be a weapon, and we try to. Although this tool we're building, given that it's smart, I think we will have the capability that has been in very few, if any, other tools to prevent as much as possible it from being used as a weapon. That's something we'll have to develop more and more of over time.
Because I was going to say, and this is, I guess, up to you guys of how you're looking to do this, but I guess there's an opportunity eventually where, this could be opened up to the app market, or and developers can develop their own stuff on it and create their own applications of it. Have you guys thought about, I guess, that process of what it looks like when it's in the world, and I guess, how people go about making, applications for it and things like that?
That's absolutely part of our plan. My Mojo's head of marketing and product, Steve Sinclair, was one of the product managers for the iPhone 1 through the iPhone 6, and he was one of the developers of the App Store. So we're very familiar with the App Store model, and going to be modeling our strategy is taking the pages out of Apple's book there.
Okay, interesting.
That's fascinating. So this means that eventually you're gonna ship out the products before launch in order to create an ecosystem of application that will be available directly at the beginning of the consumer phase of the device, or you think that eventually you will launch the application with a bunch of the product with a bunch of application that you're going to build internally, and eventually then open the ecosystem to external developers?
Yeah, again, we'll take a page out of Apple's book, and as Steve helped develop that strategy, and the first version will have applications that we've developed or perhaps developed with a small set of partners that we've already started signing up and building relationships with. And so we'll have that small set of applications that we have proven are safe and effective and work, and I won't say bug-free. No software is bug-free, but
we need to think about
really
our
well.
XR team in Accenture then.
Yeah.
Because that's an interesting point, Nick. Because we have about the enterprise. We've talked about consumer uses and stuff, but I guess, Drew, there's a very big enterprise market for this as well.
Absolutely, and we are talking with a number of enterprises in a number of different vertical markets, and we're seeing a lot of excitement for a lot of different people. We're seeing excitement from any application that needs your hands free and your eyes up. Basically, there's so many things that. Our mobile phones are incredibly useful, and there's so many applications, and you can apply the mobile phone to just about any kind of application and that you do, but it's not useful during many activities. Any activity you need your hands free, you can't use your mobile phone. You can't even use your smartwatch very well. If you're working on a car, for instance, or even if you're running, we are very excited about developing applications and shipping applications in our first version for athletics and sports. These kind of activities, you'd like technological help if you could, but your smartwatch even is too cumbersome to use while you're doing these kinds of activities. You can't play with the buttons on your watch well when you're skiing. You can't even do it when you're golfing. It's even hard when you're running, for instance, or biking. And, your mobile phone is useless. How many people have dropped their mobile phone off the ski lift, for instance, let alone try to ski down the hill with it. So we think there's a lot of applications like that, and many enterprise applications as well, where you need this kind of capability.
I can see a lot of applications eventually in the medical field for surgeons that will be able to have, for example, X-ray vision of their patients while they're operating, or MRI vision of their patients while they're operating.
Absolutely. There are applications in every field of human endeavor. In everything that everybody does, there are opportunities to use technology to help them see more, see better, see more deeply, more clearly. And we're excited to change the world in all of these areas, in every area.
And go on, Daniel.
I was going to say, I couldn't help but notice, looking through, that quite extensive CV and the companies that you've set up and founded, a lot of them seem to be based in, I guess the world of internet and infrastructure and network infrastructure. So really, I guess this feels like a bit of a step outside of that in a way. But then again, I you mentioned, 5G technology and different things like that, which I guess would have an evolution to, the way that you're looking at network infrastructure as well.
Absolutely. This is, for me personally, this is a little bit of a change in terms of market and type of application. But in terms of technology, it's just been natural. It's just incredible deep semiconductor technology and electronic technology, optical technology, software, etc. Just applied in a very different way than the broad networking. The customer base, I've always developed technology is useful for a small set of very large customers. Here, we're developing technology for everybody and everybody individually. So it's been interesting, but I've approached it the same way I've approached everything else. It's all about the team and building a team and surrounding yourself with teammates that have all the experience that you don't have and can help you. So I've surrounded myself, in this case, at Mojo Vision, first with people with deep medical experience and deep optometric experience, ophthalmology experience, and of course, deep consumer experience and consumer marketing and distribution experience, in this case, consumer tech experience.
And I wanted to, about this point, start with a provocation. There's another serial entrepreneur that is kind of working towards what you're trying to do. And I'm talking about Elon Musk with Neuralink. And he's trying to connect people's brain to computers in the cloud in order to enable super intelligence and to reduce the bottleneck that we have right now when we are talking and interacting with the digital devices. And it seems more or less kind of the same kind of statement that Mojo Vision is trying to solve. This same kind of problem that Mojo Vision is trying to solve in a different way, obviously. Do you see Mojo Vision eventually evolving into neural implants or retinal implants in the future rather than just contact lenses?
I do see an evolution of implants in some ways as well. I think that Neuralink, certainly Elon has been, I'm a fan, and he's done incredible things. And I've been tracking Neuralink technology, but I think they're missing something that we've discovered, and our technology is incredibly complementary to what Neuralink does. And I look forward someday to talking with Elon about this, but their technology is going to be great for reading signals in the brain and getting information out, a so-called brain-computer interface. But what we're developing is the world's most perfect computer-brain interface, and going the opposite way, getting information into the brain. And if you think about your brain, the majority of the biggest part of your brain is your visual cortex and everything that interprets what you're seeing. And in fact, the retina, your eye, the retina in particular, is the first part of your brain. It's literally, it's the sensors that give the highest bandwidth and most information to your brain. And nature has amazingly provided us with an optical interface to the highest bandwidth part of your brain. We don't need to implant to get to that. Okay, we can just shine light from the cornea through a contact lens to get that information in and give you everything you want. And I think these two things can work in combination. Although we also have sensors that over time will allow us to do much of what Neuralink does in terms of the brain-computer interface part as well, because it turns out that what your eyes do gives away an awful lot about what you're thinking, how you're blinking, how your eyes are moving, even how your irises are moving. Things that we can sense give away a lot. And there's a lot of research out there that allow us to think that. And being on your eye, I believe, and we haven't yet proven this, but I believe that we'll be able to detect a lot of the electrical signals that are in your brain directly from your contacts as well. So that's all future stuff that I am very excited to explore, and we've done some exploration of already. But these things are going to be complementary. In terms of going to implants, as I described how I started this with my cataract surgery, and the very first thought I had was, in fact, an implant in what's called a retinal prosthesis, and something that would interface electrically directly to your retina. And there are companies out there and technologies out there that do that, but they're extremely immature. And I thought that my second thought after having the first thought of doing that was, okay, I should pivot and do this optical interface through the contact lens instead of an implant, because I think investors are more likely to invest in that concept first. But we have actually worked on implanted technology as well with
that's interesting.
Professor at Stanford who researches this, and we do foresee the idea. There are conditions of the eye. There's people with, for example, opaque corneas, okay, that are completely blind, and the only way to fix that is to give a corneal graft and replace their corneas, and that's tried, but for some people that fails, and they're completely blind. And we believe that an implanted technology that takes the same technology that we're developing and just puts it on the other side of the cornea inside implanted can actually help those kind of people. And there's millions of people around the world that have that kind of condition, and they can't, they're completely blind. So I'm really looking forward to one day having that technology as well to help, truly blind people see. But there are many other things that can be done once we start going down the road of implanted technology in the eye.
I think this is fascinating because, there's this whole subculture, in the world that's emerged, which is like biohacking, right? Where, you have individuals who, are looking to be able to augment themselves in a way that enables them to do things that just they wouldn't be able to do before. And obviously, in most cases, we're limited. In some cases, the people, implanting an NFC chip in their hand or something like that to pay, using Apple Pay or Apple or Android Pay or to pay for something. But I guess this idea of being able to biohack, I guess yourself into a way to be able to do things that is just not humanly possible is something that's always fascinated humankind, I guess. And I'm interested to learn, because I noticed when I was looking through some of the stuff, we're talking about things like being able to do like 4 times zoom in on things and do, things like high contrast changes and stuff to help see differences in things, what in your kind of opinion then are some of those things that, from a biohacker's dream point are, those things that are going to be like the top priorities for people?
I think that's what Daniel wants to know are what, from your point of view, are the best use cases to convince your customer, yes, I want that product. Obviously, without bleeding into uncharted territory, like the stuff that I was saying before, like facial recognition or
the stuff that's going to be instant. Like someone when it does go to consumer, that's going to be the things that people can actually do, to begin with. I think we're talking about a lot of stuff that we're dreaming about right now and possible, and definitely will be possible. But I guess it might not be available in version 1, for example.
Right. So we believe that the best way to approach this and the first step is to build assistive technology to help people with, in our case, visual impairments. So we're building technology that in generation 1 will help people with low vision be able to see better. And people with low vision, there's many different reasons for it: glaucoma, retinitis pigmentosa, macular degeneration, etc. Conditions that many people get, particularly in older age, but not necessarily. Some younger people are affected by these unfortunate conditions as well. And our technology is going to be able to show them brighter images and higher contrast images, be able to show them things in low light that they would not, that a normal person would be able to see, but a person with low vision is no longer able to see, and they need help and assistance to get through life and do basic tasks, and including just walking across the room or around or reading a menu in a dimly lit restaurant. We're looking at things they can do, use edge detection technology to silhouette images and provide images that are more, that their existing retinas and their existing visual system is able to see and interpret and get through life. So we're leading with that technology, this assistive technology, and the regulatory bodies, of course, like that as well. And we think that makes a lot of sense. But then for people that are normal and don't have those kind of visual impairments, what we're doing is providing superpowers. Everything we can do is going to make superhumans with superpowers. And generation 1 is only the beginning, because over time, I think we will provide you the ability to have a 4x zoom or 10x zoom, something, be able to see further, have microscopic vision, and be able to see incredibly small things, be able to see in the dark, for instance, be able to see in multispectral fashion, like Geordi LaForge in Star Trek from decades ago. Just have incredible third sense, and as well as basically read your mind as well at the same time, and help us communicate better with each other and be able to communicate directly with each other. I'm looking forward to a day when we can speak with each other, not just in words through verbal and audio, but speak through images and speak. There have been, movies and shows on this. And if I can very quickly recall images I've seen, scenarios, scenes I've seen, and be able to transfer that to you in a heartbeat and have you see it, it'll be like you being able to read my mind, or me being able to share my mind with you. And I think we're going to speed up human communication. We're going to make communication more, clear and help get rid of miscommunication. There's so many things that we're going to be able to do with these superhuman capabilities.
You're talking about telepathy.
Telepathy. Yes.
Wow. Okay.
It'll be
that's
technology assisted telepathy, but that's absolutely where this is going to go over time. Not
So
part of generation 1, mind you, but over time.
We're talking a lot about augmented reality here, but is there a use case for this for virtual reality as well?
Like locking down completely the user only with virtual content.
One of the fascinating things about our technology, and perhaps the most fascinating experience I've had to date with this, is that our technology works when you close your eyes. So to get from augmented reality to virtual reality, all you have to do is close your eyes. And
oh, wow.
Then you can live in a virtual world. You're going to see people on the airplane. They're going to have their eyes closed. You're going to think they're sleeping, but in fact, they're watching a movie. That's what's going to happen. But, there are many applications of virtual reality that augmented reality won't be able to do. And for example, there's a lot of therapy for, mental health reasons, from anxiety to various fears, that PTSD, et cetera, that are being treated through applications in virtual reality at this point in time. And we see a day where you can take that content and those treatments and things on the road with you, the software on the road with you, so that at the moment you're being impacted by anxiety, or maybe you just need some more confidence in something you're doing, a bit of close your eyes and access your virtual reality mental health, therapy treatment, for example. And I think that's be good things. It will also be good. I'm sure there'll be good applications for communication or for accessing information of any kind, that you'll want to close your eyes and just look and not be distracted by what's going on in the outside world.
And it's refreshing to hear a CEO talking so highly about the the use cases for good that its products can have for the world, especially in a world where we're seeing a lot of people having worries about AI that could turn evil, and robo armies and drones and things like that. And I mean, seeing you so inspired by how your technology can do good for people is really refreshing, and it's a pleasure hearing you speaking about this.
Thanks.
So okay, so let's take a moment now, I guess, to just recap and kind of visit the future and stuff like that. And I think it's Nick. If we were to play buzzword bingo, is a term that comes up in every single Field of View podcast that we do, but it's Cloud XR, right? Where we talk about, the ability to stream the technology into this kind of stuff. And obviously, that's going to play a key role in this stuff. But, obviously that's one area of things. But I guess, what does this future look like now? What are some other advancements that are going to have to happen around this technology that is going to accelerate the process? I mean, we're talking about vision here, for example. What are the other aspects that come into play where we have other haptics and senses and feelings that, really make an experience as well?
Yeah, we certainly see every manner of sense being augmented at some point in time, and we're starting out with what we thought was pretty much the most difficult, which was vision. But obviously, we have a ton of technology also around audio and what you hear today. We see that technology continuing to get better, and someday for some people possibly even being implanted. It's obviously implanted in people with cochlear implants today. And we've seen technology that, you can look like a pair of braces or a small mouth guard or something you put in your mouth that can let you hear and talk with your completely imperceptibly to people. So there's a lot of technology. Smell, I'm not so sure when that comes, and have nasal implants. Not sure when that comes, but I'm sure it will. And of course, there's haptic gloves and haptic suits and things like that will give us a sense of touch. And all those things will be combined for different applications in different ways. And I'm sure we'll all continue to advance. People will continue to dream and develop new technology to implement and realize their dreams.
One of the things that you talked about is that you have this external relay that allows people, obviously, to interact with the contact lenses. Is that your main input-output, input device for the contact lenses? Are you also thinking about haptics? Are you also thinking about, finger tracking or any other kind of inputs that you can add to the contact lenses right now?
Yeah, we call it a relay because really its sole job is being a relay. Although it'll eventually have some communication, some computation capabilities and storage capabilities as well, I'm sure. But the input, the primary mode of input we have developed and is completely new and unique. We have developed a user interface based on how you move your eyes and what you look at.
Oh, wow.
And we're going to provide visual information as part of normally what we do, and just how you move, what you're looking at will allow you to input information and act like a mouse and point and click basically as you go through menus or access information or touch your touch screen, etc. So we don't need any other type of user interface, but as we've certainly discovered, even on mobile phones, there are applications where it's easier if you hook up a keyboard to it through Bluetooth or something like that. It'll be easier in some cases to speak to it and have a speech input. And every other type of device that we use to input information into our phones or into our computers will allow through a Bluetooth interface, for example, to input information. But the primary application, primary interface is simply through your eyes. It's completely natural, and we've discovered it's so intuitive and so fast. And I think that it will end up being the fastest manner of user interface, user input ever developed, really. Because what we're going to do is we all talk about hand-eye coordination and the speed of your hand-eye coordination. What we forget is that first your brain your eyes have to coordinate with your brain has to coordinate with your hands, and it's in the loop right there. And we are completely eliminating the whole brain hand part of it and just using your eyes controlled by your brain. And I think the potential for that is going to be just incredible to speed up how fast we can access information, input information, and basically think. I think that we will, being a bit optimistic here and futuristic here, but I think our hypothesis is that we're literally going to speed up human thought in this way.
Well, that's fascinating.
So in the world of like autonomous driving, it's very clear that, for that technology to work, every single car needs to be, interconnected in some way to allow them to be able to, to be frictionless. Do you feel like that's the same for a technology like this? Because, for example, I often joke about with people around, one day we're going to be walking down the street and I'm going to walk past someone and they're going to have a Snapchat filter on their face, and that's how they want to present themselves to the world. So I'm interested to know, like, if for a technology like this to really take off, do we feel that, this technology needs to be, be able to interface with one another as, to really create this kind of metaverse where, if I'm walking down the road, anyone else's augmented overlays on different things can really kind of interact with me as well?
I think this kind of technology will allow that to happen and will provide the capability for it to happen. But I think each of us will control how much that happens and what we see. And if we don't want to see somebody's avatar or their filter, we will have the ability to look through it. And I think that an awful lot of this is really going to have to be thought out from a ethics standpoint and, of course, legal standpoint. And there's going to be, over time, a whole lot of law, legislation and case law that gets worked out as society figures out which of these capabilities that we can envision, and science fiction has shown us through movies and videos and books and things, which ones are truly valuable and morally responsible, and which ones maybe not, which ones are more on the dark side and the negative portrayal of these things and capabilities. We want to make sure this remains safe, secure, private, for everybody.
Because the reason I ask about it is because I'm very well aware of, like, when we've done a deep dive previously on different online communities and the way that XR is changing those things. There's some people out there that identify purely as their online persona, for example, and how they are in the VR world is who they identify as, for example, and that's why they use the VR world to interact like that, which is where it becomes fascinating to talk about the real world. And I guess how you present yourself through AR can completely change that.
Absolutely. And some people will, I think for some people, this new capability, this new technology will allow them to go even more into the virtual world and live their life in a virtual world. That will happen. But for most people, it'll allow us to merge and merge our virtual world with our real world and have the best of both at all times, and the ideal mix of these things. That's where we want to go. So most people one of our primary goals is to, in fact, allow us to have more natural interactions with each other. Today's glasses and helmets and goggles, one of the big reasons that we're developing this technology and on a contact lens platform is that we have foreseen what's happening with the glasses and goggles. Nobody, despite tens of billions of dollars probably now being spent on this technology and in this area, nobody has come up with the kind of technology anyone wants that will look natural, will let us look like us, and let us not get in the way of communication and relationships, interactions with other people. We're trying to develop technology that is invisible. This is why we call it invisible computing, that it gives us the best of the world, best of all that virtual and augmented reality world, but allow us to look like ourselves and not get in the way, enhance our relationships with other people and our interactions with other people, communications with other people, not get in the way of them. And, but yeah, everybody's different, and, based on their own, personality, we'll want to use that technology in a different way.
No, fascinating.
Drew, thank you so much. This has been like enlightening. It's been a pleasure meeting you, and thank you for sharing all your amazing ideas about the future and about technology with us.
You're welcome. It's been a pleasure. I'm very excited to have done so.
No, well, great. Look, everyone, thank you very much to Drew. If you want to find out more information about that will be kind of linked on the kind of field of view kind of landing page. I think, for those of you that are really interested in more episodes of Field of View, we're on Spotify, Apple Music, YouTube, all of those different places. So make sure to go across, subscribe, take a look at them, and also follow us on social media. I mean, you can check out Accenture, you can check out Mojo Vision, and you can check out AIXR as well for all of the latest and up-to-date information. But truly, this has been a really futuristic episode that I'm, been really excited about.
Through accessible insights, a solid network of support, and recognizing truly outstanding achievements near or far. Big or small, we're in this together. AIXR.